Hello and welcome. Bill Judge with Monkworkz here. Thank you again for watching. And we have a bench demo on tap right now. I have the generator chucked up in a drill press, and then we have the regulator on the bench. You'll see that. First up is going to be a demo of the blink codes. So there's diagnostic blink codes that the device has that tell you when it's enabled, when it's disabled, if a thermistor is disconnected or not, and if it's in an overvoltage mode. And then we have a short circuit demo where we dead short the device. And again, it's got a current limit that it respects. It checks it hundreds of thousands of times a second and maintains the current limit. So it'll be a short circuit demo. There'll be a standby demo where there's a standby mode that the device operates in if there's another power source on the bus that's carrying the load. And finally, there's an overvoltage demo. And we'll get into some of the details about all the layers of protection against overvoltage that the device has built into it and what it does if something else on the bus overvolts as well. So anyhow, thanks for watching, and we'll talk to you on the other side.
The first part of the bench demo here is showing the blink codes, the diagnostic codes. I'll go through what the setup looks like here. Off screen, the generator's chucked up in a drill press. The three phases come out of it, come into the regulator here. Thermistor is disconnected right now. There's a connector that comes out of the generator and goes into this dummy load of 3 halogen bulbs, 20 watts each. I've got an enable, disable switch, and then the active LED. There's also a voltmeter to show how much voltage is either being applied to the regulator or coming out of the regulator, depending upon the case of the test. So I'm going to simulate you coming in and turning on your master. So I'll come in with 12.2 volts here, attach it. Right away, we see a few things happening here. So the halogen bulbs come on, obviously, so because we're applying 12 volts to them. The next thing that happens is this blink LED starts doing something. So let's watch the blink LED. You get one flash. Doesn't matter what you do with the enable, disable, you just get one flash. And if you go to your installation manual and look, one flash means that you've got your thermistor disconnected. So it's kind of obvious here. So I come in, I will feebly insert the thermistor from the generator into the regulator. And one thing I'm going to mention here is I've got pin 1 lifted right now. So on the input side of the device, you can select the output voltage to be either a primary at 14.5, 14.6 volts, or as a backup at 14.2, 14.3 volts. So with this pin lifted, you're going to see about 14.3 volts out of the device, which makes it easier for it to slide back into standby mode if there's something else providing power on the bus. So anyhow, continuing along, now we have 3 blinks, which means it's disabled. So if you go to your manual, you'll see that when you have 3 flashes, it's disabled. And that means that pin 1 and ground, pin 1 and 6 here are not connected together. If we play a little further here, I'm going to come in, I'm going to enable it, and now you get 4 flashes. 1, 2, 3, 4. And that means that enable pin and the ground pin here are connected together. Now it's disabled again. So this is just a demonstration of how you can use these diagnostic codes to find out what's going on with the device and make your installation a lot easier. So once you run your wire from a switch on the panel back to this device, I recommend you do a home run from the ground pin there and the pin 1 to the switch on your panel. Don't touch anything else en route. And once you get that installed, turn the switch on and off, and you can see that the blink codes here change along with that. And it takes a lot of the guesswork out of it. You don't have to do any probing or anything like that. It just says either IC enable or IC disable, and also I see whether or not my thermistor is connected. So I hope this is useful for you, and on to the next part of the bench demo. The next part of the bench demo here is the short circuit demo. So off screen, the generator is being spun by a drill press. it comes up online. You'll see the blink codes flash here. So 3 flashes a couple times. Then I come in, I'm going to enable it. Once it's enabled, right away, 14.3 volts comes up on the voltmeter, and you got 4 flashes. I come in with a wrench and I dead short across the terminals. You get lots of sparks. The LED is flashing. That's one of the things I want to focus on for a second here. So the LED will flash when the voltage here is below 14 volts. So in a dead short condition like this, you can see we're showing like 0.04 of a volt here. And, that's obviously well below 14 volts. So in this state, the LED is going to flash. Additional things are going to happen here too. When the voltage gets dragged below 10 volts, as it is here, the current limit is also reduced as well. So the further the voltage gets dragged down, the less the current limit is. And that's a measure to stop anything that's attached to the bus from getting damaged. So roll this again. So I'm moving the wrench in and out, unshorted, and then shorting it again here. LED flashes, voltage gets dragged way down, and then pops right back up to 14.3 volts and drives the halogen bulbs. So this is a measure to stop the device from damaging anything that's attached to it. And you'll also notice here there is a tiny little fuse, and that fuse is a backup to the electronic current limiting. So if something were to fail with the current limiting, the fuse is here, but that should actually never blow. This fuse here is rated for 30 amps, and the current limit will kick in at 30 amps in every case and stop the fuse from blowing. So anyhow, multiple layers of protection against overcurrent situations here. This next part of the bench demo here is going to show the standby mode. So I'm going to start by applying a power supply at 14.4 volts to the halogen bulbs. Right now, that's the only source of power. In the background, you're going to hear the generator get turned on by the drill press. I'll pause it, mute it. A couple things are happening here. Internal to the regulator is going to do a self-test. You'll see the active LED flash just for a split second, and then it goes back into standby state. And it will remain in standby state. And you can enable, disable, whatever. Nothing's going to happen until you take the power source away. And then briefly, you saw the voltage drop there, but it comes back online almost immediately. And then something else happens here. After 5 seconds of reattaching the load, the active LED goes out again. I remove the power. It's active. It's carrying the load. I bring the power supply back in. You wait 5 seconds. It realizes that something else is carrying the load, and it goes inactive again. So I disconnect the power. It picks up the load. You saw a little short flash in the lights, but sometimes I don't get the alligator clips in there right, so it picks up the load. But it's back at 14.4 volts. You count for 5 seconds. It goes inactive. Take it away. It's back at 14.3 volts, and the generator is carrying the load. And you can switch back and forth like this all day long. If your other power source is coming on and off the bus, the regulator will cooperate nicely with that and pick up the load when needed, and then go inactive when it's not needed. So this is the overvoltage part of the bench demo here. So I'm going to spin up the generator here. Kind of noisy, so we'll pause and mute that. And a couple things are going to happen here. I'm going to come in with 15.5 volts and let it go a little further here. So generator's up and online now. So this is me coming in with a power supply, 15.5 volts. And just like in the standby mode, all of the current is going to shift to the power supply, and the generator will go back into its quiescent state. But because I've got this set for 15.5 volts, it's going to shift into a different mode. It's going to shift into an overvoltage mode. So I'll let it come in. Okay, and if you look at the blink LED now, there's 2 flashes. And so we'll pause for a second. So 2 flashes, if you go to your manual, means that the device is overvolted. And when it goes into this overvoltage mode, it waits to see that the bus comes back in line. The same way it does from the standby mode, it waits to go down to 13.7 volts before it considers coming back online. But an additional step is put in. It's going to go through a self-test and make sure that the redundant means to shut down inside the regulator is still functioning. So it checks the redundant means for shutdown on startup every time the aircraft is started up, but it's also going to check it after each one of these overvoltage modes. So there's an additional pause, and the reaction is a little bit slower after an overvoltage event here. And this is just a precaution to make sure that if indeed it was an overvoltage mode, we want to make sure that the shutdown means that this device has are still available. Now, that's a precaution against the Monkworkz regulator overvolting your bus. So there's at least 3 measures against overvolting your bus here. There's the normal regulation where it's maintaining its output voltage, and then there's a hardware check to make sure that the voltage is within limits. There's an analog to digital converter that looks at the output voltage, and the microcontroller decides whether or not the output voltage is within limits. And then finally, there's a tertiary precaution with a transient voltage suppression diode, a TVS diode, that can sync up to 45 amps when the voltage exceeds 16 volts. So, somewhere around 15.2 to 15.3 volts, the Monkworkz regulator goes into this overvoltage mode, and it waits to see if the bus comes back down to 13.7 volts before it tries to do anything. And then it does its own internal test. Now, if the voltage continued to rise because there was something else on the bus, then the Monkworkz regulator would start using that transient voltage suppressant diode and start to sync current. Obviously, if you've got something overvolting on your bus like that, you should get that fixed. But there's a bunch of measures here with this device to stop it from overvolting your bus. So we'll let it continue here. I take away the voltage, and then you can see it comes back online, but it's a little bit more of a hesitation before it comes back online. And this is how the device reacts to an overvoltage from something external. And again, there's, unless the device is malfunctioning, it should not ever overvolt, but it has its own internal checks against what it's providing to the bus. And if the bus is out of line, then it will kick itself offline. It'll do an internal self-test and bring itself back online after it's convinced that it will still be able to shut itself down, and it gives itself 2 more chances to support the bus before taking itself offline completely. One thing I want to stress is that while we have lots of measures in place for overvoltage events, I haven't actually observed any overvoltage events either from other alternators or from my device on any aircraft in the test fleet or in the ones that are in the customer's hands. So, these overvoltage events are incredibly rare, and the thresholds that we've used to set them appear to be not kicking off lots and lots of false alarms or anything like that. So these are incredibly rare events, and I want to stress that the 3 strikes and you're out type thing here, if that actually happens, then there probably is some kind of real problem either with the Monkworkz regulator or with something else on your electrical system. So anyhow, just a little bit more information for you, and thanks for watching.
Welcome back. Thanks for watching this far. I really appreciate it. Hopefully that was illuminating for you and how this device works and how it might work in your airplane. If you have any questions, please hit us up. Again, monkworkz.com with a Z. There's phone numbers and email addresses on the website. The installation manual is there too, has all the details. And we'll be putting out another video at some point on how you do an installation. So I hope this is helpful, and if you have any questions, hit us up. Take care. Thanks again for watching. We'll see ya.